So now let's talk about concentration. That's a term I'm sure that you're familiar with, but let's give a technical definition of concentration. Concentration is the amount of a substance in a defined volume. Now it's important to note that the behavior of a chemical often depends on its concentration. The experiment that we looked at previously, 9.2, where we wrote down the chemical equation for that precipitate would not have formed unless the concentration of those compounds were sufficiently strong in each of the solutions that were combined together. Okay, so concentration is important to make sure that we get the behavior out of these compounds that we expect. When we talk about concentration mathematically, I know you're waiting on some math stuff. So if we talk about that mathematically, we need to discuss the term molarity. All right, and so let's give you an equation for molarity. Molarity, we're going to abbreviate that as a capital M, is the unit that we'll use, one unit anyway, that we'll use for concentration. And molarity is equal to the moles of solute divided by the liters of solution. So even though technically the unit is moles per liter, we're going to abbreviate that with a capital M, which means molarity. Okay, so let's do an example and try this new equation that you know out. Example 9.2.
So this is how example 9.2 reads. It says a solution is made by measuring out 150 grams of calcium nitrate. We've written that down right here. And dissolving it in enough water to make 500 milliliters of solution. The question is, what is the concentration in moles per liter? So we remember our equation for molarity is moles of solute over liters of solution. So first we have to determine the number of moles of solute by converting this 150 grams of calcium nitrate to moles. We know how to do that. We've done that before using the atomic mass, and once we determine the atomic mass for the compound, we can determine the number of grams of that compound that you have per mole. And so I've basically calculated that out for us here for calcium nitrate, and we've determined that for every you have 1 mole for every 164.1 grams. So let's do that conversion. Let's convert 150 grams of calcium nitrate. Remember, we know that it's calcium nitrate because we have looked at our chart on page 245, and we've seen that that nitrate is NO3, and we determined, just like we did before, what the appropriate formula would be for that compound as we looked at the charge on both calcium and the nitrate polyatomic ion. So 150 grams times 1 mole of calcium nitrate is equal to, as we've calculated up here, up top here, 164.1 grams. And so when we multiply that out, our grams of what? Calcium nitrate. So when we multiply that out, our grams units will cancel out here, and we're left with moles, and that comes out to be 0.9141 moles of calcium nitrate. Now, we're almost there. We said that the equation for molarity was moles of solute, which we just determined, over liters of solution. We're not given liters of solution, we're given milliliters of solution. So we do need to convert that to liters. We know that for every 1 liter, that we have 1,000 milliliters. And so that gives us 0.5 liters of solution, right? So now let's calculate molarity. Molarity, remember that we represent that by a capital M, is equal to the moles of the solute, 0.941 moles of CaNO3 divided by the number of liters, which is 0.5 liters of solution, and that's going to give us 1.828 moles per liter. But remember, that's not how we write this unit. Our unit for molarity is actually a capital M, so our final answer is going to be 1.828 molarity.
So when doing chemistry experiments, we often have chemicals that are already dissolved in a solution. And so since they're in a solution, we don't do our measurements in grams, right? We're going to use a volume unit. We're going to use something like liters. And so with that in mind, let's do another example, which is example 9.3.
Now in this example, we're told we have 175 milliliters of a strontium nitrate solution. So 175 milliliters of strontium nitrate. Says if the concentration of the solution is 1.4 molarity, how many moles of strontium nitrate do you have? So we want to know the number of moles. How many of those do we have? May not be immediately obvious that you know how to do this problem, but you actually do, and it's probably the simplest one we've done so far, because we remember that the equation for molarity is the moles of solute over liters of solution, right? So the unit is moles per liter. When we say 1.4 molarity, we mean 1.4 moles of solute, right, per liter. All right, so remembering that, that should tell us that if this is in milliliters, we need to first convert it to liters. So 175 milliliters, again, 1 liter is equal to 1,000 milliliters. So that's going to be equal to 0.175 liters of strontium nitrate solution. And then since molarity equals the number of moles per liter, we just say 1.4 moles per liter times 0.175 liters of solution. And when we multiply that out, our liters units are going to cancel out, and we're left with 0.25 moles of strontium chloride. So that's the number of moles, I'm sorry, not chloride, strontium nitrate. That's the number of moles in our solution.
So that's it for today. I hope you know more about mixtures than when we started. But all this talk of mixtures has got me thinking about my afternoon coffee break, so I think I'm going to go enjoy it. What's that? Oh, what's the switch for? Huh, let's find out.
What's up? Day going all right? Good, good. So did you hear the one about the guy that ordered the homogeneous coffee instead of the heterogeneous coffee? Yeah, he just wanted to stir things up. uh, yeah.
Weird.